Hello everyone. Welcome back to the classroom. Today we are going to discuss about a few numerical problems in transportation planning. It is me Dilruba KM. Let's dive directly into the contents. So in transportation planning, we have four types of numerical problems. One is in trip generation stage where we will be developing some equations in order to define the trips. And second one is about growth factor method, in which we are going to uh, provide the trip distribution in the future by using various methods like uniform factor method, average factor method, frater method, furnace method. And the third type of problems are about model split, means it is a model development which predicts the probability of using of the mode which can be provided in the scenario. From using logit model, you can predict which mode of transportation will be used above the others. And the last type of problems are in traffic assignment, in which we will assign routes for the traffic. After all these types of steps, we finally reach the traffic assignment step. Without any ado, let's begin the trip generation problems. In trip generation problem, we are mainly dealing with linear regression. So for example, let's have a problem. Let the trip rate of a zone is explained by household size. Fit a linear equation relating trips per day and the household size, and calculate the trips generated by the household size of 10. So household size means number of people residing in one household. Okay. So household size 2 means it is a house in which two number of persons are living. So from this table you can see that one person household with one size have making a trips of 5 per day, whereas household with size 2 are making a trip 10 per day, and household size 3 have 13 trips and 4 has 18 trips. Now we are asked to find a linear equation which relates the number of trips and household size, and also calculate the trip generated if the household size was 10. So the basic equation of linear regression is y is equal to a plus bx, where a and b are two coefficients. X is the independent variable. In this case, household size is the independent variable and y is a dependent variable, means y depends on x. So number of trips are depending upon the household size. In order to find out b, we have an equation n into sigma x into y minus sigma x into sigma y divided by n into sigma x square minus sigma x whole square. You have to by heart this equation in order to do this math. Where n is the number of data set. In this case, we have 4 set of data. So n here is 4, and a can be calculated using the equation a is equal to sigma y minus b into delta x divided by sigma x divided by n. So in order to make this problem easier, we have to make a table by writing x, y, x square and xy, so that we can calculate the sigma x, sigma y, sigma x square, sigma y square and sigma x into y. So just applying all the values, you can see x square means each of the x's square. So 1 square is 1, 2 square is 4, 3 square is 9 and 4 square is 16. It is 4 here, sorry, a small mistake. It is 4 here. And x into y, which is 1 into 5 is 5, 2 into 10 is 20 and so on. Now when you apply all these values, you can find that b obtained as 4.2. From the value of b, you can calculate a as 1. If you have a and b, then we can develop the equation from the base equation y is equal to 1 plus 4.2 into x. So this equation describes that if you have household size x, that into 4.2 plus 1 will give you the number of trips. So from the question, it is asked to find out the number of trips generated by the household size of 10. We are applying the value of x as equal to 10 in this equation. Then the answer you obtain is 43. Okay, now let's see another example. In this particular example, tip rate of the zone is explained by the household size done from the field survey, and it was found that household size 1, 2 and 3, 1, 2, 3 and 4, the tip rates for the corresponding households are given for 3 days, 3 separate days. And we are asked to fit a linear equation relating the trip rate and household size. From this table, you can see that household size x values are 1, 2, 3, 4. But we have 12 set of y values. So, for each household size, for example, we are taking household size 1. The day 1 trips per day was 2, and day 2 it was also 2, but on day 3 it became 3. So we cannot take 2, we cannot take 3. Instead, we have to take the average of all these things. How can we find the average? We will sum up and divide it by total number of data set. So here we have 3 set of data and sum up. When you sum all these y values, for household size 1, sigma y is 7, and 2 it is 12, 19 and 23. So we will not be taking y as 7, 12, 19, 23. Instead, we will be taking the average. Average means 7 divided by 3 will be our y for household size 1. 12 divided by 3 will be the size of household size 2, and so on. So we have the same basic equation, same equation for B, same equation for A, but in our table we have to take the y as 7 by 3, 12 by 3, 19 by 3 and 20 by 3. The 7, 12, 19, 20 are the total sum of the trips per day in each of all the days divided by total number of days. Okay. So you have x value, you have y value, just find the x square and x into y. Apply it in the equation B and A, you will get equation y is equal to a plus bx. So the linear equation which relates trip rate and household size is trips per day, which is y is equal to 1 plus 5.35 into household size x. So this is the equation that is to be developed. So that is all about linear regression. Now we are moving to growth factor method. Growth factor method is mainly about trip distribution. We have majorly 3 types of growth factor method. In this video I am only focusing on first 2, that is uniform factor and average factor. So in growth factor method, what we do is we are going to predict the trip distribution. Trip distribution means it is the number of trips from each zone to other zones. Say for example, if you have a trip from zone I to zone J and growth factor E, just multiply the present trip with growth factor, you will get the future trip from zone I to zone J. It will be clear when you are going for the numerical problems. I can give you a more explain. I can explain more. Okay. Now just remember that this is the basic equation of growth factor. Capital Tij is equal to small tij into E, where I is a zone I and J represent zone J. So capital Tij indicates it is a future number of trips from zone I to zone J. Small tij indicates present number of trips from zone I to zone J. In order to calculate the growth factor, you can divide capital Tij to small tij, where capital T is the total future number of trips and small t is the total present number of trips. The limitation of this uniform factor method is we are just blindly multiplying all the trips of the present trip distribution with a growth factor, which may not be uh, reliable, because not all zones will be developing the same way, right? So that is the main limitation. uh, the positive point of uniform factor method is advantages. It is the most simplest and oldest method, so it's very easy to calculate compared to other methods. Now let's look into some examples. The first example, here the trip distribution of present trips among zone 1, 2, 3 are given below. Future trips are 400, 560 and 720, 1, 2 and 3 respectively. Distribute the future trips among the zones by using uniform factor method. So this table is called OD matrix. O stands for origin, D for destination. So OD, origin destination matrix, this matrix indicates that from 1 to 1 means within the zone 1, total number of trips are 60. Within the zone 1 to 2 means zone from 1 to zone 2, there are 100 number of trips occurring, and from zone 1 to 3, 200 number of trips are occurring. Okay, so this is 2 to 1 means from zone 2, 100 trips are occurring to or moving towards zone 1, and from zone 2 only 20 trips are within zone 2 itself, and from zone 2 to zone 3 there are 300 number of trips. So this is our basic OD matrix, base year matrix. Now we are going to prepare a future OD matrix by using the uniform factor method. So in uniform factor method, we just have to find out the total trips. Okay, for zone 1, the future trip as given in the question as 400, and we will calculate the present trip. Present trip is the just summation of all the trips in zone 1, 2 and 3. Okay, so sorry, zone 1 60 plus 100 plus 200, which these are the trips starting from zone 1 towards zone 1, 2 and 3. So the total it comes 360. And for zone 2, the future trip is given in the question as 560, and the present trip is 100 plus 20 plus 300, which is 420. And from zone 3, future trip is 720 and present trip is 520. So in order to calculate the growth factor, we will just find the summation of future trip and present trip. Future trip divided by present trip will give you growth factor of this OD matrix. So we got growth factor as 1.292. Now we are going to multiply that growth factor with the present trips. So just multiply each and every Tij with 1.292, which is the growth factor. Sorry. So you will get the future OD matrix. So this is the OD matrix of zone 1, 2 and 3 in future. Okay. So this is called uniform factor method. This is one of the most easiest method in the entire growth factor methods. Now let's move into a little bit difficult method, which is called average growth factor method. So in this method, it utilizes growth factor for each zone within the study area. Unlike uniform factor, it is not going to multiply the same growth factor with every numbers. Instead, they will find growth factor for each trip with respect to their growth factor at origin and growth factor at destination. Okay, so here you have to understand there are two E's, two growth factor at origin, which indicates EI, and EJ indicates growth factor at the destination zone. Okay, so we have to do the same iteration again and again until we get all the growth factor near to 1 or equal to 1. So let's see how can we do this. So in this particular example, we are asked to determine the trip interchange, means we have to find the OD matrix for the study area where 3 zones using average growth factor method. Here growth factor GF is given, and OD matrices 1, 2, 3 is given as 20, 30, 10, 40, 15, 20, 20, 10 and 20. So we have growth factor. So growth factor for 1 is zone 1 is 1, zone 2 is 3 and zone 3 is 2. So we just mark growth factor EI and EJ 1, 3, 2, 1, 3, 2. Now we are going to multiply each term with average of the growth factors. So this is our basic equation. So for T11, which is trip occurring from zone 1 to zone 1, which is 20, that 20 into 1 plus 1 by 2, which is again 20. Now coming to next, T12 means trips starting from 1 ending at 2, which is 30. So 30 into 1 plus, what is the EG of 30? It is 3. So 1 plus 3 by 2, which is 60. Now coming to T13, it's 10. Its EI is 1, EJ is 2. So 10 into 1 plus 2 by 2, which is 15. And for 40, it is 40 into 3 plus 1 by 2, which is 80. And so T22, 15 into 3 plus 3 by 2. And for T23, 20 into 3 plus 2 by 3 and so on. So you do the same thing. This for T31, it is 20 into 2 plus 1 by 2. For T32, it's 10 into 2 plus 3 by 2. And for T33, 20 into 2 plus 2 by 2. So you get the next OD matrix, which is 20, 60, 15 and 80, 45, 50 and 30, 25 and 40. So you get all new OD matrix, which is a future OD matrix. Okay. Let's see another problem. So in this particular problem, distribution of present trip among zone 1, 2, 3 are given. Future trips for zone 1, 2 and 3 are expected to be 360, 1260, 3120. Distribute the future trip among zones using average factor method. 2 iterations means we have to do it twice. Growth factor for origin and destination zones are equal. So let's see how to do it. In the previous problem, they have given a growth factor directly, but in this problem, they have not given the growth factor. Instead, we have to find growth factor. So we just draw this OD matrix with all the values given. Then this is the future trips. 360, 1260 and 3120. This is the present trip. Present trip is the summation of the trips. 60 plus 100 plus 200, which is 360. 100 plus 125 plus 30, which is 255. 200, 320, which is 520. Now you can calculate the growth factor by dividing the future trip to present trip. So here it is 1. Here it is 1260 by 255, which is 4.94. And here it's 3125 by 520, which is 6. As per the question, growth factor for origin and destinations are equal. So we are just keeping all the growth factors same for the zone 1, 2, 3 in destination also. So we have 1, 4.94 and 6 in the as EJ and EI. Now we are going to start our iteration 1 calculation. So this is our basic matrix with EI and EJ. Calculate 60 becomes 60 into 1 plus 1 by 2, which is 60. And 100 become 100 into 1 plus 4.94 by 2, which is 297. 200 is 1 plus 6 by 2, which is 600. And everything. Do the same for all the rows. So you will get the values as 297, 6, 17.5, 164.1 and so on. So for every trips between I and J, just multiply the present trip with average of the EI and EJ. So this is our iteration number 1. Now we got a new OD matrix. Using this new OD matrix and keeping the future total trips constant, we have to find the new growth factor. Okay, so we have new audiometrics and future trips remains the same, but the present trips changes. Present trip is the summation of total trips from each zones. So here the present trip is 60 plus 297 plus 600, which is 957. 297 plus 617.5 plus 164.1, which is 1078.6, and so on. Okay, then find out the growth factor. Growth factor is future trip divided by present trip. So our aim is to make the growth factor 1. We have to do the iteration until then, but since in this particular question they have asked you to do only 2 iteration, you can stop after this. Okay, so we have EIs, and same EIs are applied in the EJ, and our using the audiometrics we can repeat the same procedure. 60 into 0.376 plus 0.376 by 2, which is 22.56. 297 becomes 297 into 0.376 plus 1.16 by 2, which is 228.096, and 600 into 0.7376 plus 1.26 by 2, which is 490.8, and so on. So you have to do the calculation by yourself, and please check the answer with this without don't try to blindly copy down it. Just do it by yourself, and if you have any doubts you can comment to this video. Okay, so now we are moving to another type of probleming average factor method. So in this previous question we had growth factor for origin and destination as the same, but in this question, look at the question, we have zone 1, 2, 3 and their future production and attractions are given. Okay, and 1, 1, 2, 2, 3, 3, these are blanks, which means the trips within the zone is considered or is neglected, is considered nil. They didn't consider the trips occurring within the zone. So we have only few values, only 6 values, but we have production and attractions are given. So we have to find EI and EJ separately. Okay, so we have the future trips, future production, future attraction. Now calculate the present production, which is 100 plus 200. Here it's 400 plus 600, 500 plus 300, 800. Now you can calculate EI as future divided by present. So you got 24 and 3.75. And in the case of attraction, for attraction of the zone 1 is present attraction is 400 plus 500, which is 900, but future is 2000. And present attraction of zone 2 is 100 plus 300, which is 400, but the future is 1500, and here the present is 800, future is only 400. So you have to find the EJs, growth factor for destination. 2000 by 900, 1500 by 400, and 400 by 800.5. So you have EIs and EJ. Now let's begin the iteration number 1. Again, multiply 100 with 20 plus 3.75 by 2, and 200 becomes 200 into 20 plus 0.5 by 2, and 400 becomes 400 into 4 plus 2.2 by 2, and so on. Do the same thing that we have done in past 2 problems, and you will get new audiometrics. And making this as base metrics, do the second iteration. So you have the new audiometrics. Using the new audiometrics, calculate the present trip again, calculate the present attraction again, and find the growth factor for production and attraction, and using that calculate the new future production and attraction. So you have done the 2 iterations. So all these things are the same thing, just the difference is in the first average growth factor problem, growth factor was given. In the second, they have mentioned growth factor for both attraction and production are the same, and they have provided only future production. But in third one, they have provided future production and future attraction separately. So you have to find EI and EJ separately and do the math. So the calculations are same, but they can be asked in different ways. Okay. So the basis of this is simply multiply the present trips with growth factor of origin and growth factor of attraction of that trip and find the average of them. Okay. So that is all about growth factor method and average and uniform factor method. If you have any doubt, please feel free to comment. Thank you.